We've talked about inheritance, and we looked at interfaces. Interface is a contract that specifies certain methods that all the classes that implement the interface must implement. But today we're going to talk about a different kind of inheritance called subclassing. So let's start with another look at turtle. We've looked at this before. A class turtle, each turtle instance has an XY position and an angle orientation. It has public methods called turn left and go forward. And there is a constructor that puts the turtle at a certain spot and with a certain orientation. And turtle is not an interface. It's not just a list of public methods. It is actually a class, and we can see that it doesn't implement any interface. I can use turtle to draw a square like this. I create a turtle instance and put it in a position, and then I go forward and turn left, and we do that 4 times, and we've drawn a square. So here we go. There is a square drawn by the turtle class, or an instance of a turtle class. Now I want to change turtle to draw colored lines. So I could modify turtle itself, but instead I'm going to extend it. I'm going to use inheritance to create a new class that is the same as turtle but can draw with colors. I'm going to call it color turtle. Okay, so at the moment it's simply an empty class, but I'm going to add here, after the name color turtle, I'm going to say that it extends turtle. So it's an extension of the turtle class. What does that mean? It means that color turtle will inherit all the fields and all the implementations of class turtle. So it will have private fields X, Y, and angle. It will have a turn left method and a go forward method, and I don't have to write any of I don't have to repeat the code. It's automatically inherited when I say extends turtle. There is one problem though. So a color turtle is now a kind of turtle, and a turtle needs to be constructed like this, with these 3 parameters to its constructor. But I can't inherit this constructor just as it is, because it is called turtle, and in class color turtle the constructor must be called color turtle, and it needs these 3 parameters because it's a kind of turtle, so it needs to be, I need to be able to construct it in the same way as I would construct a turtle. There we go. Okay. So there's still an error, and that is because when class color turtle inherits from turtle, it must inherit the turtle part of itself by calling this constructor. So class turtle has this constructor. Color turtle is a kind of turtle, so it needs a similar constructor but with the right name, and it needs to call this previous constructor. And the way it does that is to say super, which is a keyword in Java, and it refers to the instance of turtle that color turtle inherited from. So I'm going to say turtle x0, y0, a0. So let's just recap. Color turtle extends class turtle. It inherits all the fields and all the methods, even the private ones, but I need to replace the constructors explicitly. And every constructor in class turtle, and in this case there is only one, needs to be replaced by a similar constructor in class color turtle with the right name that calls the previous constructor. It is also allowed to do other things, as we'll see in a second, but it must do at least this. Okay, so now I'm in a situation where color turtle and turtle are exact copies. Apart from the name, they do exactly the same thing. So why did I do this? Because I want class color turtle to have some extra functionality. I want it to have a color that it's going to use for lines, color, that class turtle does not have. So here I'm adding an extra field, class color turtle. It still has the X field and the Y field and the angle field, but it now also has a color field. And I can, in this constructor, I can add additional commands after I call the super constructor. I can say color is color.black. Okay. Now I probably also want some additional methods. I may want to be able to change the color of this color turtle, color equals C. So I can give it different colors. Okay, so let's just think where we are. Color turtle extends turtle. It inherited all the fields and these methods, and I've added this field and this method to change the color, but when it draws lines, it is still going to use this inherited method that draws a black line, and I want to change that. So I'm going to replace this method, the implementation of this method in color turtle, with its own implementation. So it's going to draw lines in a different way. Now for the most part, it still needs to do this, but there is an easy way for me in color turtle to call the go forward method of its superclass. So I can say super.goForward. Right. So whenever a color turtle needs to draw a line, it will simply call the inherited method to draw the line in class turtle. One thing that we've already seen is that I can add this annotation override. As you can see, it's not necessary. If I leave it out, Eclipse and Java are happy. But I tend to put it in to make sure that everyone can see that I'm overriding the implementation of go forward. I didn't need to do it for set color. In fact, I'm not allowed to. If I try to do that, it'll say there is no set color in type turtle. So I can't do it there. I don't do this for constructors either. It's not appropriate to constructors. Is disallowed for this location? Yes. Okay, right. At the moment, go forward in color turtle does exactly the same thing as go forward in turtle, but I want to change that. I want to change the color of the pen when I draw a line, and it's going to change it to its color field. So color turtle remembers the pen color. I can change it whenever I want, and then when it draws a line, it uses that pen color. Okay, so let's see how we can change square. Here is class square, and it creates a turtle and issues these commands. But now I'm going to write a new program called color square, and color square will use a color turtle, create a color turtle, and then before each line I want to change the color. I'll just use two colors. Set color to be color.red, and then it draws two lines, and then let's make it blue. And let's run this, and there we go. So here is a square drawn with a color turtle, and it has two different colors. One last thing is that what if I change square so that I create a turtle, but I create an instance of color turtle. As you can see, there are no errors. This is allowed because every color turtle is a kind of turtle. So T is a turtle, and it's just pointing to this color turtle, but all these commands are valid because a color turtle behaves exactly like a turtle. I have modified some of the methods, but in this case it doesn't make a difference. Every color turtle is a kind of turtle. Let's make it the other way around. Can I say color turtle T is a new turtle? I can't do this because a turtle is not a kind of color turtle. It's the other way around. We'll talk more about this relationship in the next video, but this is enough for now. Let's just have a look at this class again. So I can save a lot of work. I don't have to duplicate all the methods. I only have to repeat the methods I want to change, and even then I can use the method of the superclass to do some of the work for me. Let's end it there, and in the next video we talk more about the relationship between this kind of inheritance and interfaces.